Yeah, and you can always see how the data looks like on
able to see the first 10
and then I did all that.
data set, and then like suddenly
Okay, so these are what it would look like if you had been able to pull it up here.
information
So
in the
this is
world
the
that they
first
can
step.
use to change it for the better.
So this is just a
we're
random
thrilled
ID
now.
that's assigned,
Okay,
the
so let's
age
go
of the people,
to line 30.
their height,
Because
their weight.
sometimes it's very important to know what the hell you're dealing with, right? So you might read in an R data file, for example, and have no clue what it is that you just brought into your machine, but you know it's there, right? So what you want to do is get an idea of the structure and maybe the class of the data that you're dealing with. So structure, with regards to a data frame, will spit out the class of the data object for each of the variables, right? So some of these are not numbers, right? Polsci is not something you learn when you count to 10. Rather, it is a socially determined attribute that defines what it is we do. So you'll see character next to that variable name, telling you this is text. The other one's integers, meaning you can run all kinds of quantitative statistical analyses on these because these are numbers. I know it seems meaningless, but it is important to know, especially when you're unsure or unfamiliar with the data that you're dealing with. So you can get an even more micro level and specify it on the variable, right? So let's say I really want to know the class of the ID variable, right? I got to know if this is an integer if I'm going to start running some stuff on it. Well, luckily I can just do class, my data, $, because the US has a hegemony over ideas in the world, ID, and then it'll tell you what the hell that is, okay? And you can do that with other ones, like major, and it'll tell you, oh, that's character, right? And finally, unfortunately not for you, you can use the view function on line, oh, I lost it. The one that says view, my data, and it'll show you the same thing that it shows you when you click, okay? I'm showing you this because it's important to do as much as possible without using click and go. Many times, you will have the opportunity to use R through a remote session where you may not have access to a mouse, right? And so you have to do everything through a keyboard. And so you really got to talk the language that R is speaking. But this lets you inspect it. More fundamental stuff. Let's go back to the script, right? We'll move on to step 4 and start looking at summary statistics, which is what you were probably hoping to start getting into today. And luckily we made enough time because I was enthusiastically militant. So let's see what the average age of the respondents in our data set is. Oh, the average person is 19.83 repeating years old. Very specific. We all know that's not the case.
So
that's just the mean, the distribution of the data that we have there. But
mean and then command enter?
yeah, 37. Is everybody able to get that? You may not get the exact same response as me. So there are actually parameters that determines how many significant figures R is going to spit out for you that differ not only by operating system, but by your computer generally. You can specify those. It's somewhat more of a technical thing. But don't be concerned that you didn't get 19.8333. You got 19.8, that's totally fine.
No, I got
Point is, it spit out a value. That's the average age. Did anybody not get that? Sweet. Sweet sound of silence. Simon and Garfunkel. Okay, let's try the median. Oh, 19.5. Brilliant, right? That's a different number. We now know that there's a skew in this distribution. We can like really probe into what the hell's going on with the data generating process behind age. There's nothing. We can do that with the other ones, like on average, how many days out of the week do college students drink? Oh, just under 4. Having a good time. What about the number of drinks when they do? Ooh, 6. People are going a little crazy. I wish I sampled people. This is a totally random data set.
So you guys are just running these operations as you go along.
So eventually, like, the goal is to be able to write your own script so that when you input data, you can write down like what it is that you're trying to figure out, and it'll just calculate all of that for you.
Let me clarify the reason that you folks have this script.
Yeah.
You will never use this script again. You will bury it deep in the folders of your cloud or your hard drive, and you will probably only ever look at it when you start your own project and you're like, oh, how the hell do I figure out how to like get the mean? Or how do I figure out what class of data object this is? Or what are the parameters for reading in a CSV? You're going to come back to this. And that's the reason I was really adamant on Meredith that we have a script that we give to you folks. Because that's the beauty of all this. Learning R is really only through what everyone else gives you. It's a totally community-based thing. And anyone who tells you otherwise is wrong.
So are these
Okay.
are all what what he means by data frame?
Was everybody able to get to the average number of drinks that a student has in a given week?
So
Yeah?
these are just exploring
Cool.
your data.
Okay.
And these are
Now we're
actually
going to start
trying
judging
figure
ourselves
out,
as
like,
how much we drink in
what
relation to
is
this number.
the average
Don't.
age?
We can also look at
What is
the average
number of
for
days
political science
you try
students, right? So let's say that we have this ongoing hypothesis that legal studies students drink a whole lot more than political scientists because they're wound up with the actualities of the execution of this social thing we call law, right? And so they just gotta put a few more down at the end of the night. What we can do is look at the subpopulations and specify the mean or the average for those subpopulations, right? So let's head to lines 44 and 45, and you'll see the average number of days that political science and legal studies students drink, respectively. And it seems we have confirmatory evidence of our initial hypothesis. It shows that there is at least one more day of the week when legal studies students are imbibing, in which political scientists are maybe theorizing, or using intoxicants of another sort, but I won't advocate that here. We can also look at the number of drinks. So let's quickly cycle through lines 47 and 48. Weird.
Wait, is 48 supposed to be legal?
It is. It is. It's definitely supposed to be legal. I appreciate that. So quickly change line 48 within the quotations to legal. Oh, not only do they drink more days of the week, but they drink more on the days that they do drink. That's telling, guys. I hope none of you legal studies, your livers won't be happy. Is everybody comfortable where we are? Please don't be silent if you're falling behind. It's very important to make sure that we all keep up with the pack. Like I said, this is a community thing.
Does it matter where your cursor is when you click?
No.
Okay.
No. So if you're following like a linear progression of lines, you can just keep ramming that control enter until you hit the end of the script and your computer yells at you. Or sticky keys gets turned on.
Or you could just Control A, select the entire script, and hit run.
But everyone successfully operated through line 48, right? Awesome. We're halfway through, guys. This is cool stuff. Okay, so maybe I'm not so concerned with the average age, but I really want to know, out of these legal studies students, like what's the range? What's the minimum and maximum age of these students? Well, we can use the command range to figure that out, right? So students in these classes are between 18 and 22 years old. This sounds like a pretty standard college class, right? We can also look at the range of the number of drinks, right? Because maybe it's interesting that people have 6 a night, but like, what if there's someone who has 20, right? That's of interest. So you want to see the range. Oh, wow, okay, so someone in this data set has upwards of 12 drinks a night, right? Yeah, but our average is actually kind of right in the middle, which tells us, if any of you have statistical knowledge, that this is a somewhat normal distribution, right? But range is another important and interesting way to look at your data and to get a feel for it, right? Because remember, what we're dealing with is a series of a bunch of observations relevant to a particular phenomenon. And what you have is basically, if you did a histogram, a distribution of values, maybe like that, right? And so when you're getting the average, you're only right here. But it's interesting to see how far it spans, right? Or maybe if the median is somewhere farther off from that. These are the reasons that we have these differentiated tools for looking at different parameters of the distribution, and they can all come into play when you run a quantitative study. I'm sorry for my sniffles, folks, UMass plague. So, we can go a little bit farther than range, median. Are most of you acquainted with the notions of variance and standard deviation? Who isn't? Okay, so variance and standard deviations are ways of describing how frequently and at what rate basically we move away from the average, right? So, in a normal distribution, you have basically 2 standard deviations covers something like 95% of the data, right? So knowing that standard deviation can give you a good gauge of basically, like the range, where most of the data is falling between, right? Because say these tails here are basically meaningless populations, like we really don't need to worry about that. Knowing the increments at which we move across the value of the distribution helps us know how it's shaped, how to interact with it, different things like this. So we can get the variance of the number of drinks with line 54, and we can get the standard deviation with 55. Standard deviation is just a function of the variance, just so that you know. Standard error is another one. But these are summary statistics. And if one day you're doing a ground-shaking analysis of, the determinants of a meaningful human life, and you need to know the standard deviation of like the distribution of happiness, you can turn back to these commands. So everyone got the variance and the standard deviation? Great, good, awesome. Let's move on to step 5. Data analysis, as we all know, is only a successful profession because we can make really pretty pictures out of numbers, right? You've all read articles where they put up like, a glorious network of something, or you see this really intricate histogram, right? Quantitative political science would not be nearly as mainstream as it is if people were putting up huge matrices of data in their papers, right? Rather, what they do is they visualize these in a kind of a shortcut way. So here are a few different ways that you can visualize the data that you have. The first one is, as I was suggesting over there, a histogram. So with line 59, we can look at the distribution of the number of drinks that students drink on a given day. There is a parameter to this command called breaks, and you can specify the number of bars basically that you want. This may seem arbitrary, but with regards to large-scale data analysis, it's actually somewhat meaningful how many breaks that you insert in there. And so instead of 10, you can actually incorporate a function that R has and substitute in quotation marks FD. And it will scale the number of breaks that you have to the size of your data so that it is representative in what it is presenting, right? So the 10 was a little bit of a liberal estimate on my end. We don't really have enough data to justify having 10 breaks in our histogram. R seems to think that we should only have 3. But you're scientists. You can do what you want. So specify how you will. Same goes for line 60. So we can look at the distribution of the number of days out of the week that people drink. Seems to skew right. Sad tale about college students. But yeah, this is one way of looking at your histograms. They're a little lackluster now because you only have 20 observations, but they're really cool ways of kind of getting into the subpopulations of your data, seeing the way that it's distributed, the skew, and trying to infer from that a little bit. Was everybody able to get a histogram? Got one here, got one there, this is good news, good stuff. You got one, you got
When I
one.
did FD, it said I got an error.
Sweet.
I
Awesome.
got
Even
an-
tests.
Well, I got an error.
You got an error.
Yeah, when I changed the 10 to FD.
Oh, okay. So it's important to know that if you don't put something in quotation marks, R will think it's an object,
Oh.
like my data.
So I have to
Right.
put the FD in quotes.
So if you're using FD for your breaks, put it in quotation marks.
Okay.
Yeah, there you go.
Okay.
Perfect. Awesome. So
Okay.
we're prepared to move on to a different kind of visualization. Are we?
But so how do you know what to put? Like if it's not a number, you have to put it in quotes?
Yes.
Okay.
Yeah. So like within this parameter, FD is a way of referencing a particular function that determines the number of breaks that's appropriate for the sample size that you have, right? So it'll give you, like, instead of 3, if you had like 1,000,000 observations, it would give you a bunch, right?
Okay.
Because that's a way of
So
basically keeping you honest.
can you just repeat FD references? What did you just say?
FD is short for the name of 2 statisticians who came up with a way of determining what an appropriate number of bars for a histogram are based on your observation count, right?
Okay.
So we'll call them like, I don't know.
But so by putting FD there, what you're doing is you're referencing something that allows it to make a determination about how many bars there should be instead of you
Within-
telling it what to do.
Within the histogram command,
Okay.
right? So the histogram command has this built-in functionality where it's like, hey, you don't have to think too hard, I'll do this for you.
Okay. So then R makes the decision about how many.
But it's only within that command, right? So you can't just go around anywhere else where you want a specific value, just plug in FD and expect it to do it. That's
Okay.
just for the histogram, okay?
Okay.
Awesome. Are there any questions, confusions about histograms?
Would you call this a crash course?
I would call any introduction to R.session a crash course.
Okay, that's fine.
I pray none of you are alienated from the rate at which we're covering this material. I promise you it gets much easier as you acquire more information, which is the very reason I'm here. So are we all comfortable with histograms? We're gonna like print out a picture, put it above our bed, and like watch it while we go to sleep at night? Maybe not, it's not that pretty. But we can go into bivariate statistical analysis with something like a scatter plot, right? So that's not, histograms are the only way you can look at your data. So we can head on over to lines 63 and 64 and look at, for example, how height is related to the number of drinks that a given person has, or weight for that matter. Again, these are not real data, so there's not gonna be a meaningful relationship out of this. This is just a way of showing you how you can juxtaposition 2 of your variables and plot where the points meet for each observation, right? So let's just quickly run line 63. And each dot there is one of your observations, right? So observation 1, for example, has just under 55, inches for height, and they have about 1 drink a night, right? But that's one of them. And each bubble represents one of the rows in our data frame, again, an observation. And the y-axis represents the number of drinks, where the x-axis represents the height. We can do the same thing with weight. That's far more random. It seems that people are not self-conscious with how much they drink. That's awesome, that's great, we shouldn't shame. These are 2 ways of looking at your data. They're a lot of fun, they're helpful for getting an idea of the distribution. That's a word I keep bringing up. I promise it'll become more meaningful. The fun part about R is when you get to create variables of your own. And you get to give them their own names, you're basically their parent, right? So you can assign, for example, to the letter V, the number 2. And all of a sudden, in the top row there, you will see that V means 2. Within the world of R, V and 2 are equivalent. They are two sides of the same coin. They cannot be separated until you unassign that value from the letter V.